All right, so in this lesson, we are going to write the slope-intercept form. We're going to write the slope-intercept form of a linear function, so a line, given a table of solutions. Given a table of solutions. So we're going to write this y equals mx plus b equation that goes with these solutions. So I'm going to be given these solutions that make an equation true, and I'm going to write that equation. Let's not forget that our m is our slope, which is our constant rate of change, and this is how we move. Or it's useful to think about it as how we move. And this plus b will be our y-intercept. Let me change that color. So our y-intercept. Our y-intercept, which is, well, it's useful to think about it as where we start. Our starting point. I'll just put start. So let's go ahead and first, let's find our y-intercept. Our y-intercept, remember, is b. It's where we start. If you notice, the y-intercept will always be 0, comma, something. 0, comma, something. So in this example, our y-intercept is 0, negative 2. I'll draw that with a little more space. Our y-intercept is 0, negative 2. It won't always be at the top. Sometimes it'll be down here or off of the table, but it will always have a 0 for the x. Now the y-intercept now the slope on the other hand, the slope is m. Our constant rate of change is m. We have to actually work for this one, it looks like. So we could do this. But if I know that these create a line or that this is a constant rate of change, I could actually go somewhere down here. And I should get the same answer. So 1 plus 1 is 2. 9 plus 3 is 9. It might show up differently, like it might be like 2 over 6 or 3 over 9, but eventually, like when you simplify it, it'll be the same. Let's just check it just for fun. So negative 2 plus 1 is negative 1. 0 plus 3 is 3. All right, that's nifty, that's cool, that's fine. So I should actually write this somewhere. So that's a positive over a positive, so I get a 1 over 3. We'll just write it right here. A positive over a positive is a positive, and I get 1 over 3. Another way we can write that is 0.33 repeating. Let's go ahead and write our equation that goes with these x's and y's, with these solutions. So y equals, I'll write this one in blue actually. Y equals, our slope is 1 over 3, 1 over 3x. Our y-intercept is 0, negative 2, so we'll put minus 2. So let's do this. Maybe this would be helpful. 1 over 2 x, and then we will put minus 2. Oh, I don't know what I'm doing right now. 1 over 3 x, and then we will put minus 2. So 1 over 3 from here, and minus 2 from 0, negative 2. And of course, we can write this a bunch of different ways. So y equals 0.33 repeating x minus 2. We could also put the value, put the 2 over here. Remember, the 2 has a negative value. So negative 2, and then this is positive, plus 1 over 3x. Let's make that a little bit. Okay. And lastly, y equals 2 plus, negative 2 plus 0.33, repeating x. Now, we want to prove that these, in fact, go with these solutions. We want to prove that these solutions make these equations true. All right, so let's just use one. I'm going to choose 9, 1. I'm going to choose 9, 1. I guess I'll just do it like that. 9, 1. Remember that 9 is my x, my 1 is my y. So I'm going to do, I like this first one. Y equals 1/3 x minus 2. I guess I should use just something to differentiate it. So this 9 is the x, it goes right here. And this 1, that's the y, goes right here. So 1 goes right here. Equals 1/3, and then instead of the x, I'm going to substitute in 9. And then minus 2. So my left side, when I'm done, my left side should equal my right side. So a positive times a positive is a, let's write that way. 1 equals. Positive times a positive is a positive. 1 times 9 is 9. 9 divided by 3 is 3. And then we bring down this minus 2. And 3 minus 2 is in fact 1. And 1 does equal 1. The left side is in fact equal to the right side. Let's do it again. All right, so example number 2. The y-intercept, let's start off by identifying the y-intercept. Y-intercept is b. I'll write that a little better. B. Remember that the y-intercept will always be 0, something, right? But I don't have 0, something here. So I need to find it. I need to uncover it. So I will do that by using the constant rate of change. So change in y can go over here, and the change in x can go over here. Changes in x. So right here, the y will decrease by 3 when the x increases by 4. And we can even see it again if we want to show it. Remember though that it doesn't have to show up the same way. Like this could be show up as 6 and 8 or something. These will all have constant rate of change, so you only really need to show it one time. And then let's go backwards to hopefully get back to 0. So instead of adding 4, we will subtract 4 when we get to 0. That's what we wanted. And instead of subtracting 3, going backwards, we will add 3. So 14 plus 3 is 17. And then we can go, well, we can stop right here. It's 0, 17. We've accomplished our goal. But I just feel like doing it one more time. Minus 4 is negative 4. And then plus 3 is 20. And remember though, this right here, go, 0.17 is our y-intercept. 0.17. And let's look for our slope now, or let's identify our slope, which is m. If you see here, it is a negative over a positive, which is a negative 3 over 4. 3 over 4. Now, even if you use this other version, you would get a positive over a negative, would still be a negative. And another way you can write that is negative 0.75. All right, so let's go ahead and write our equations. So y equals, our slope is negative 3 over 4. Negative 3 over 4. we'll put x. And our y-intercept is positive 17, so we will put plus 17. Let's go ahead and write that in different ways. So y equals negative 0.75x plus 17. Y equals positive 17. And remember, that's positive, so 17. This is a negative, so I'm going to put minus 3 over 4x. And then y equals 17 minus 0.75x. Cool. Let's go ahead and show some proof of this. Remember that our goal was to take these solutions and find the equations that go with all of these, right? And go with this pattern of solutions, because we can keep making more, right? So let's go ahead and, 8, 11. I'm going to choose 8, 11. I'm going to get a little small. I think we might need some room. 8, 11. All right, and I'm going to write it like this. Well, you know what? I'll just write it out. Okay, so we have y equals negative 3 fourths x. You know what? I'm going to use a different equation. I'm going to use this one, different version of it. 17 minus 3 over 4x. Now don't forget that this 8 is our x, that 11 is a y. The 8 will go here, the x goes here, and the 11 goes here. It doesn't even look like an 11 anymore. Do what we can though. So 11 goes here, and 8 goes here. Cool. You know what? I'll put that in purple. Not that it makes too much of a difference because we can't really see it that well. But just in case you care. Just in case it helps. So 11 equals 17 minus 3 over 4 times 8. I'll put a little longer. 3 over 4 times 8. So the next line is 11 equals, I don't know what to do with my writing. 11 equals 17. A negative times a positive is a negative. 3 times 8 is 24. 24 divided by 4 is 6. And 17 minus 6 is 11. Awesome. And that is it. Thank you.